Today we are going to learn about optimizing data pipelines for LLM training, focusing on streamlining data processes to enhance training efficiency and boost model performance. Welcome to our video on optimizing data pipelines for large language model, LLM, training. In this session, we'll explore the critical role that data pipelines play in the training of LLMs. A well-optimized data pipeline ensures that your model is trained on the highest quality, most relevant data, which directly impacts its performance and accuracy. We'll cover essential topics including data preprocessing, selecting relevant datasets, data cleaning, normalization, and more. By the end of this video, you'll have a comprehensive understanding of how to streamline your data processes to enhance the efficiency of LLM training. Let's get started. Data preprocessing is a critical step in preparing datasets for training large language models. It involves a series of operations that transform raw data into a format that is more suitable for model training. This process includes cleaning, normalizing, and formatting data to ensure consistency and quality. For LLMs, preprocessing is particularly important because it ensures that the data fed into the model is relevant and free from noise, which can significantly impact the model's learning process. Common preprocessing techniques include tokenization, removing stop words, and stemming, among others. A robust preprocessing pipeline leads to more accurate and efficient model training, ultimately enhancing the performance of your LLM.
Selecting the right datasets is crucial for training a large language model that meets your specific objectives. The relevance of the dataset to the model's intended tasks directly influences its ability to learn and generalize effectively. When choosing datasets, it's important to ensure that they align with the model's goals and cover the necessary scope of topics. Evaluating the quality of datasets involves checking for biases, ensuring a diverse range of examples, and verifying the accuracy of data. A well-chosen dataset not only improves the model's performance but also reduces the risk of overfitting and enhances its ability to handle real-world data.
Data cleaning and normalization are essential techniques for ensuring the quality and consistency of datasets used in LLM training. Data cleaning involves identifying and correcting errors, removing duplicates, and handling missing values. This step is crucial for eliminating noise and ensuring that the dataset is as accurate as possible. Normalization, on the other hand, involves transforming data into a consistent format, which is vital for models to interpret it correctly. Techniques like scaling and encoding are commonly used to standardize datasets. By maintaining high-quality data through cleaning and normalization, you significantly enhance the reliability and performance of your LLM. As the volume of data required for training LLMs continues to grow, managing large-scale data storage solutions becomes increasingly important. Scalable storage options such as cloud-based systems and distributed databases offer the flexibility to handle large datasets efficiently. When selecting a storage solution, it's important to balance cost and performance, ensuring that data is both accessible and secure. Consider factors like read/write speeds, redundancy, and backup capabilities. Additionally, security is a key concern, as protecting sensitive data is paramount. Implementing robust storage solutions ensures that your data pipeline can support the demands of LLM training without compromising on quality or security.
Data augmentation involves creating additional training data from existing datasets by applying various transformations. This process enhances the diversity of the data, which is particularly beneficial for LLM training as it helps models generalize better. Common data augmentation techniques include synonym replacement, sentence shuffling, and back translation. While augmentation can significantly improve model performance, it's important to maintain a balance between augmented and original data to avoid introducing bias. By implementing effective data augmentation strategies, you can enhance the robustness and adaptability of your LLM, leading to improved accuracy and performance in real-world applications. Automating data pipeline processes offers numerous benefits, including increased efficiency, reduced manual errors, and improved scalability. Automation tools such as Apache Airflow, Luigi, and Prefect enable you to streamline data workflows, schedule tasks, and monitor processes. By reducing the need for manual intervention, you can focus on more strategic tasks and ensure that your data pipeline can scale to meet growing demands. Automation also improves the speed of data processing, allowing for faster iterations and more timely insights. Implementing automated data pipelines is a key step towards optimizing your LLM training processes, ensuring that your models are always trained on the most current and relevant data.
Ensuring data quality and consistency is vital for the effective training of large language models. High-quality data leads to more accurate models, while inconsistencies can introduce errors and reduce performance. Regular quality checks and audits are essential for maintaining data integrity. Tools such as Great Expectations and TensorFlow data validation can automate these processes, providing insights into data distributions, detecting anomalies, and verifying schema adherence. By prioritizing data quality, you enhance the reliability and effectiveness of your LLM, ensuring that it can deliver accurate and dependable results in real-world applications. Regular evaluation and updating of data pipelines are essential for maintaining their effectiveness and relevance. As data sources and model requirements evolve, pipelines must adapt to accommodate these changes. Key indicators of pipeline performance include data throughput, error rates, and processing times. Regular assessments help identify bottlenecks and inefficiencies, allowing for targeted improvements. Updating pipelines may involve integrating new data sources, refining preprocessing steps, or enhancing automation. By adopting a continuous improvement mindset, you can ensure that your data pipelines remain optimized for LLM training, supporting the development of more accurate and robust models over time. In conclusion, optimizing your data pipeline is a crucial step in ensuring the successful training of large language models. Throughout this video, we've covered essential topics such as data preprocessing, dataset selection, data cleaning, and automation. Each of these steps plays a vital role in enhancing the efficiency and effectiveness of your LLM training processes. By implementing the strategies discussed, you can improve model performance, accuracy, and adaptability, ultimately leading to better outcomes in real-world applications. As you move forward, remember to stay updated on the latest developments in data pipeline optimization and continuously seek opportunities for improvement. Thank you for joining us, and we wish you success in your LLM training endeavors.